So students, today we will discuss about the noise and control. That is the sound pollution and control. That is our module 5 and lecture 23. So these are some of the objectives of the class. First, we discuss about the noise. What do you mean by noise? How we can define the noise? Okay. Next, we will discuss about what are the characteristics of noise. Next, we will discuss about the classification of noise. That means what are the types of noise we have generally. So that we will discuss. And next, we will discuss about the decibel unit, which is very important because from this decibel unit, you can have so many numericals based on the whatever expression today we will discuss. Based on that expression, you will have so many numericals. Okay, so very frequently you can have the problems in your exam, so you should understand well, otherwise you cannot solve the problems. So these are the objectives of the today's class. Okay, next, sound and noise. What are the differences between sound and noise? So generally sound, we can define the sound like a pressure variation, that is a wave that travels through air and is detected by the human ear. Okay, so sound is a pressure variation wave function, right? It can travel through the air and or any medium and detected by the human ear. So this is called sound. Now noise, so sound obviously a wave function. That means we can, this is a wave function, so that means the sound wave function we can express like this. Understand? Now come to the noise. Noise is excessive or unwanted sound which potentially results in annoyance and or hearing loss, and can be from the occupational on or from any industry. It can be from any road traffic noise. Okay, so these are the definition of noise. That means the excessive unwanted sound which is very harmful for us. If we are hearing the noise for so many long time, what will happen? We can have the hearing loss, we can have the headache, we can have some of the mental problems. Okay, so mental problems and also some of the health problems, health issues, that also we can have while we are exposing to the higher intensity sound. Okay, so that is called the noise. Now here you can see two pictures, picture number 1 and this is picture number 2. So by observing these two pictures, you can very easily it is very obvious that the picture 1 is the sound wave function and the picture 2 is that wave function, while is not random, is very random, not maintaining any periodicity. Okay, so you can see the amplitude, the wavelength, all are different. Okay, so this is called noise and this is called sound. Okay, the sound, that means the sound is very pleasant to us, while it will maintain some of the periodicity. Understand? And which our ear can detect. And noise is the excessive unwanted sound, while that wave function is not maintaining the periodicity. At some point it will be very high, At some point it will be low, the amplitude will be very high, the amplitude will be low. That this type of wave function is called by the noise. Okay. Now, noise is unwanted, irregular, unpleasant, and annoying sound, which I have already told you. That is with no musical quality. Exactly, musical quality, musical sound is very refreshing for us. Why? Because the wave function is periodical. Whatever its amplitude, whatever its wavelength, all are the constant. Okay, so that is why it's called musical. Okay, but for the noise we don't have any musical quality for the noise. Okay, so that is why the noise is very unwanted and unpleasant. Next, what are the characteristics of sound as well as the noise? As the sound or noise both are the wave function, that means some of the characteristics we have for a wave function, like pressure, intensity, frequency, wavelength, amplitude. So these are all the characteristics of a sound of a wave function by which we can define a wave. Okay, so among them the two important parameters of the sounds are, that is the pressure and intensity. Okay, so now we will discuss about the frequency. What is frequency? Frequency is the number of wave passing through a point in 1 second or per second. Number of oscillations per second is called frequency. Okay, so if this is a wave function, that means while this is a full wave. Okay, so while this wave will complete one cycle, so the complete its full cycle, so how many cycles like this we have in per second, that is called by the frequency. Understand, the frequency, that means per second how many full wave we have, how many cycles of the wave we have, that is called frequency. Now the SI unit is hertz or cycles per second. The range of normal perception for young person, that should be 20 to 20,000 hertz. That means if the sound in frequency will be 20 to 20,000 hertz, that sound will be audible for us, that sound we can hear. Understand, so that is why so 20 to 20,000 is the limited value. So while the minimum, that 20 to 20,000 hertz frequency will be there, that sound we can hear, that will be audible. Okay, and the unit of the frequency is hertz or cycle per second, as I told you. Now pressure is another important characteristic parameter of the wave, of any type of wave. That is, pressure is the force per unit area. Thus the sound waves creating pressure on the medium through which it propagates is measured in Newton per meter square. That means the sound is a wave and that wave function can propagate through any medium. Understand, air through water, through metallic body. Okay, so how much force it will create per unit area, that is called by pressure, and the unit of the pressure is Newton per meter square. Okay, so this is a wave function. Now look, this is between this distance is called by lambda, that is the wavelength of the wave function, and or this or wavelength is this distance. Okay, And amplitude, what is amplitude? The height of this, that is called by amplitude. Okay, so these are the some of the characteristic parameters. Like so first of all we have the frequency, next we have the pressure, next we have the wavelength, and then we have the amplitude. Okay, so this is called by, these are the some of the characteristics of the wave function that can be defined, a wave function. Okay, next, decibel. Frequently we can hear that 100 decibel sound, 80 decibel sound, 60 decibel sound. So what are this? Decibel, actually decibel is the unit of what? Unit of the intensity of the sound. So intensity, the unit of the sound intensity is the decibel. Okay, generally sound intensity, if it is 0 to within 100 decibel, it will be it will be measurable. Okay, bearable. But if it will exceed 120 decibel, and then finally it will, if it exceeds to the 130 decibel, that will create some of the biochemical effects on any type of living systems. Okay, so these are the, this sound intensity is very high, and this is very harmful for us. We can have so many types of disease for this high intensity sound, that we will discuss later, the effect of noise. Okay, now the sound more than 130 decibel causes the sound pollution. Exactly. So sorry, yeah, common unit, this decibel, it is actually, what is decibel? Decibel, actually it is the ratio of measured intensity and the reference intensity. So this is the, sorry, this is the main equation based on which we can have to um, solve so many problems. Excuse me. Yeah, decibel, that is decibel equals to, you can see, that is 10 log 10 I by I0. Why, where I? What is I? I is the measured intensity. Okay, and what is I0? I0 is the reference intensity. Right, now what is reference intensity? Reference intensity is, that is, yes, this is our reference intensity. I0 equals to 10 to the power minus 2 watt per meter square. So reference intensity, generally the intensity that we can hear, the minimum intensity that we can, that is audible for us. Okay, and whatever measured intensity, that means whatever sound we are exposed to, that is, if we calculate, if we determine the intensity of that sound level, that is called by measured intensity. Okay, so this is the classification of noise. Now next topic is our classification of noise. Generally, noise are of three types. One is transport noise, one is occupational noise, and one is neighborhood noise. Transport noise, occupational noise, and neighborhood noise. Okay, so these are the three types of noise that we have. Now transport noise. What are these transport noise? Again of three types. One is road traffic noise, railway traffic noise, and aircraft noise. So road traffic noise means whatever the sound we are exposed to in the roadside, uh, that all type of sounds, noise are called by the road traffic noise. For the relay traffic noise, that means the whistle, the horn. So these are the some of the relay traffic examples of relay traffic noise. And aircraft noise means like while the landing, during the time of takeoff, during the time of landing, whatever the noise is created, that is called by aircraft noise. Okay, so these are the three types of noise that we have for the transport noise. And what are the occupational noise? Now occupational noise generally, uh, like from industry, whatever we are getting from the industry, but whatever we are getting from any type of institute, that is called by any type of institute, or any type of market, shopping complex, marketplace. Okay, so these are the some of the yes, these are the some of the occupational noise that we have. So like from any industry, there are so many instruments, so many machines working. During their working, while whatever noise is created, that is called by occupational noise. From any marketplace, like from the loudspeaker, if someone is using the loudspeaker, so whatever noise is created, that is called occupational noise. Or any type of institute, from any type of institute, the noises, whatever noise is created, that is called by, whatever noise is created, that is called by occupational noise. Now neighborhood noise. So neighborhood noise, what are the neighborhood noise? Neighborhood noise means like I'm sitting here, and beside my room someone is listening music very loudly. Okay, so that is called by, what will happen, that is called by yeah, so that is transport neighborhood noise, generally that is called by neighborhood. Like beside my room, beside me, whatever noise is created, that is and by that noise I'm feeling uncomfortable, that is called by neighborhood noise. Okay, so these are the three types of noise that we have. Okay, so now we acha, one more thing, students. Acha, first you should know. Acha, here the reference intensity will be 10 to the power minus 12, not 2. Okay, this will be 10 to the power minus 12. Right, so decibel, look here, I'm again repeating decibel, that means the unit of the intensity, right? And that is the ratio of the measured intensity of the exposed sound and the reference intensity. What is the reference intensity? That is the I0, and that is 10 to the power minus 12 watt per meter square. Mind it, the unit is watt per meter square. Okay, so this is the reference intensity, 10 to the power minus 12, not the 2. Okay, so 10 to the power minus 12 is the reference intensity. Now based on this equation, we will solve some of the problems. So these are the three types of noise already we have discussed. Yeah, so your first question is, what will be the intensity of 100 decibel sound? Intensity of 100 decibel sound. That means the decibel, the value of the decibel is given. Now what you have to do? You have to calculate the intensity of the, that means the measured intensity that you have to calculate. Okay, so dB, decibel, equals to your 100. Yeah, this is the actual equation, that is decibel, that is dB, equals to 10 log 10 I by I0. I is the measured intensity and I0 is the reference intensity. Okay, now I0 already I have told you, I0 is the 1 into 10 to the minus 12 watt per meter square. 10 to the minus 12, okay, not the 2. 10 to the minus 12 watt per meter square. So this is the I0 value. Now look. Yeah, so decibel value is given. That means 100 decibel is given. So 100, we have written here 100, right? Now 10 log 10, your I by I0. Here we have put the value of the I0. Here we have put the value of I0. That is 1 into 10 to the minus 12. 10 to the minus 12, mind it. 10 to the not minus 2, minus 12. Okay. So 100 equals to 10 log 10 I by I0, that is 1 into 10 to the minus 12 watt per meter square. Yeah, so after this, that means we have 10 equals to log 10 I by again I0, that is 1 into 10 to the minus 12 watt per meter square, right? Is this clear? Yeah. Now the next step, look at the next step. Look, so what will happen from here? How can we get here? How? If we remove this log, what will happen? Whatever the base is, that base come here. This is the base. Okay, so this base come here, and whatever in your left side we have remaining, that will be the power of our base. Understand? So if we want to remove this log, how can we do that? By base, whatever the base is, the base come here, and whatever in left hand side we have, that will come to the power of the base. Is this clear to all? Yes. Okay. Next we have, that is equals to I by I0. So again, the I0 value you know, that is 1 into 10 to the minus 12 watt per meter square. Okay, so that means I equals to 10 to the minus 2. So thus we can get the value of the I, right? Yes. So this is the intensity of 100 decibel sound. So answer is, the intensity of 100 decibel sound is 10 to the minus 2 watt per meter square. The unit is 10 to the minus 2 watt per meter square. Okay. So this will be the intensity of the 100 decibel sound. Okay. Next question. Next question is, how much is a sound of 100 decibel is louder than a sound of 80 decibel? 80 decibel. Okay, so here 2 decibel values are given. One is 100 decibel sound and one is 80 decibel sound. So you have to judge which is the louder one. Okay, so what? Sorry. Yeah, so these decibel values are given: 100 decibel one sound and second sound is 80 decibel, right? Yeah, so this is the equation: decibel equals to 10 log 10 I by I0. Again, I0 is the reference intensity, and that you know, that is 1 into 10 to the minus 12. 10 to the minus 12. not 10 to the power minus 2, right? So 1 into 10 to the power minus 12 watt per meter square, that is the reference intensity. Yes. So this is the reference intensity. Now, yes. So 100 decibel sound, again 100 decibel. We have put here the value, that is 10 log 10 I by I0 value. This is the I0 value, right? Okay. So again this will be, so this will be 10 equals to log 10 I by I0. Next, again we have to remove this log. So what we have to do? Yeah, we have to do what? Whatever the base, that base will come here. And at the left hand side, whatever we have, that will come as a power of that base. Understand? So 10 log 10, that is equals to I by I0, and which is 10 to the minus 2 watt per meter square. So this much intensity we have got from the 100 decibel sound, right? Now the same thing we have to do for the 80 decibel sound also. Yeah, 80 decibel, again we have done 80 equals to 10 log 10 I by I0. I0 value is 1 into 10 to the minus 12 watt per meter square. Okay, so this will become 8. Yeah, 8 equals to 10 log 10 I by I0, right? Now again we have to remove this log. So what will happen? Look here, the base will come here 10, and whatever our left hand side, that will become the power of the base. Understand? That means 10 to the power 8. That is equals to I by I0. Is this clear to all? Yeah. So next we have, so I prime, yes, as we have used I here for the 100 decibel sound. So here we have used as the I prime. So I prime equals to 10 to the minus 4 watt per meter square. So this intensity we have got from the 80 decibel sound. Okay. Now what is the ratio? If we do the ratio, then we will get the ratio, that is 10 square. Understand? So thus we can calculate the 100 decibel sound, how much is the sound of 100 decibel is louder than the 80 decibel sound. Thus we can do. So we have to that means we have to, for each case we have to calculate the intensity, the measured intensity first we have to calculate, and after that we have to just after that we have to just do the ratio, and then we will get the answer. Okay, how much is the 100 decibel sound is louder than the 80 decibel sound. So these are the some of the types of problems, numericals, that you have generally in your exams. Okay, so first of all you have to memorize this decibel, the equation of this decibel. Okay, so after that you can solve any type of problem very easy. You just have to put the data. First of all, check the question, whatever they're asked. Okay, so according to the question, you have to solve the problem. Okay, so very easy. Only some of the tricky portion here, if if you remove the log, then what will happen? The base will come here, and at the left hand side whatever we have, that will come as a power. So these some of these things that already you know from your mathematics knowledge. So these are the some of the things that we should remember, and after that we can do the problems properly. Okay. Very easy problem. So next day also we will solve some of the numericals based on this equation, some of the other type of numericals that we will discuss. Okay, so this is a quick review. Whatever I have discussed so far, how much you have got, for checking that thing, I have given one question, that is sound pressure level can be defined as. So you have 10 seconds time. You have to think about this, and then you can do your you can get your answer. Yeah, your 10-second time is over. Now tell me, yeah, I think you have got your answer, and the answer is sound pressure SPL, that is sound pressure level, that is equals to 20 log P by P0. Again the same thing, like the decibel, the same thing, the like P by P0. P is the measured pressure of the sound that we are exposed to, and P0 is the reference pressure, that is 2 into 10 to the power minus 5 Newton per meter square. As this is pressure, that means force per unit area. Pressure is force per unit area. That is why we can write down like P by P0. P0 is the reference pressure, that is 2 into 10 to the power minus 5. Okay, so these type of some of the numericals also you can have, numericals, and also the MCQ. Some of the MCQ also you can have, the like what is the expression of sound pressure level, what is the expression of decibel unit. Okay, so what is the reference intensity of the sound, what is the reference pressure of the sound. So these are the some of the types of MCQ that you can have generally in your exam. Okay, so very easy question. You if you follow the classes properly, then you can solve, you can answer the questions, and also you can do the problems, you can solve the problems. So problems are also very easy, and also next day we will again solve some of the more problems. Okay, so again this is a recapitulation. So today we have whatever we have discussed, the topics that is the definition of noise, exactly the characteristics of noise. Generally noise are three types. One is what are the types, that is the transport noise, occupational noise, and the neighborhood noise. So these are the three types of noise that we have. Sorry, this is a classification. Yes, the characteristics of noise, generally what we have, that intensity, pressure, wavelength, amplitude, so the frequency, these are the some of the characteristic parameters by which we can define a wave function or a noise. Okay, and what is a decibel unit? Decibel unit, that means that is 10 log 10. Yes, 10 log 10 I by I0. I is the measured intensity and I0 is the reference intensity. Mind it, reference intensity is 1 into 10 to the power minus 12 watt per meter square. Minus 12, not the minus 2. Okay, so 1 into 10 to the power minus 12 watt per meter square. Okay, so this is the decibel unit. Understand? So all this we have checked. Yes. Okay. Okay, thank you students. So please follow my classes properly, and whatever I have given you, the assignments related to noise and related to the previous class also, you have to submit the assignments within the time. Okay, thank you students. Have a safe day.